All right, so welcome back. Today in this video, we are going to be looking at structural engineering. Now, this is the 11th topic out of 14 as you're studying for your Civil FE exam. All right, and today we're going to be looking specifically at analysis of statically determinate beams, columns, trusses, and frames. So I have a few practice problems that I want to go and walk with you through. And then I'm going to be given some extra little prior knowledge things that you'll need to know, or conceptual things that could really help you for this section. So let's go ahead and dive in. This one, number one, says an overhanging beam with a length of 6 meters has a concentrated load of 8 kilonewtons applied at the free end. Additionally, there is a uniformly distributed load of 2 kilonewtons per meter over the entire length. Determine the static determinacy of this beam. Okay. So what information are we given? All right. We are given all of the applied forces. All right. I have that kind of already shown, I believe. So we have applied forces that we're given. We're also given that it is an overhanging beam, right? So what is an overhanging beam? Well, if I draw this, right, overhanging beam, I would assume similar to, it's like a cantilever beam, and there is a fixed support, and then they said that there's a concentrated load coming down for 8 kilonewtons, and then they also mentioned that there's a uniformly distributed load of 2 kilonewton meters over the entire length. So I'll just say we got some uniform load coming down, and that is going to be 2 kilonewtons per meter, right? Okay. So what are we trying to find? We're trying to find the static determinacy of the beam. Right. Okay, so what formulas might we need for this? So if you don't know, which I'm gonna pretend as if I don't know, I would start by looking through the handbook, right? And if I'm trying to find static determinacy, then I probably would search. The best thing to search would be determinacy to figure out what that even is, right? Okay, so if I search determinacy, there's 3 things that come up. All right. Stability, determinacy, and classification of structures. Okay. So with this, basically, you can find whether something is stable, unstable, or and statically indeterminate or statically determinate. And that's what our answer choice is pretty much asking us for. So we need to look at this and determine what the number of members would be. So I would specifically use this the frame equations down below, and I'm gonna zoom in so you can see it a little bit better. So the variables that we would need would be m, which is the number of members, okay, R, which is the number of independent reactions, and then J is the number of joints, or C is the number of condition equations based on eternal moment or forces such as internal moment. Okay, at a hinge. Right. Okay, so I'm going to say that we're going to need to use this 3m plus r, and we don't know what the symbol is, so I'm just going to say equal to start. So this equation is the same except for one would be less than, one is equal to, or one is greater than. So I'm just going to choose the equal to for now, but once you plug in your members, reactions, it's going to tell you which one is correct and how to classify it, whether it being unstable, stable, and statically determinate, or stable and statically indeterminate. All right, so we have 3m plus r is equal to 3j plus c. All right, what would m be? M is equal to the number of members. Right? So we just have literally one member there, right? So I would put m is equal to 1. What about r? R is equal to, what does R mean? Number of independent reactions. Okay. So reactions, if you have a support, then that support has reactions, right? And so for a fixed support, how many reactions would you have? Well, let's draw them out. We got I'll just say this is point A and this is point B. So we have a Y reaction, we have a X reaction, and then we also, with fixed supports, you have a moment. So you have a moment about A. I'm just gonna call it that. So how many reactions is that? Well, you got 1 in the Y, 1 in the X, and then your moment. So that's 3. You have 3 reactions. What about joints? Joints is equal to, so joints is how many particular places that your beam or your frame, I count them as glued to a certain piece. So this is to connect the two, you need your fixed support and your beam. So that's one joint. So they're joined together. So this will be 1. What about C? There's no internal hinges or anything. So C is going to be internal moments either. So there's C is going to equal to 0. So when we plug this in, we get 3 times 1, right? Plus 3 times 1 plus r, which is 3, is equal to 3 times j, which is 1 plus c, or 0. Okay, so 6 is what? Greater than 3. Okay, so being that 6 is greater than 3, right? I know that I'm using this one, and so I know that it's stable and statically indeterminate. So this is going to be stable and statically indeterminate, which would be C in this case. Now, there's a few other things that you want to make sure that you know, right? Sometimes they'll ask you, well, to how many degrees is it statically indeterminate, right? So because it is for this side, it's 3. Basically, I guess how to best explain this is if something is statically indeterminate, it has a certain amount of degrees to where it would be able to even out the equation. And so for this to be able to even out the equation, you would need 3 more on the other side to be able to even it out. So it's statically indeterminate for 3 degrees, basically, to the 3rd degree. Rather. So if the equation came out to be 5 to 1, right? Then this would be statically indeterminate to the 4th degree. Okay, and so on and so forth. So just something to note. Another thing, you're not always going to be given a fixed reaction, right? So good review. How many reactions are on a pen? So you have 2. And so, right, we have our in the X direction and in the Y direction. What about for a roller? Call that a pen. Anytime you see a triangle, that's typically a pen. All right, anytime you see a circle, it's typically a roller. So the roller only has 1 reaction. And then that's symbolized as a roller. Other things. Oh, your joints change. So I'll just draw this, right? I'll draw a beam. How many joints would be on this particular beam? Yep. So you got a pin, a roller, and a fixed joint. So every time, remember, every time it's glued to something or stuck, that's where a joint goes. So to be able to connect your beam to your pin, that's 1 joint. It erases every time I do that. Okay. So to connect to my roller, it's another joint. And then to connect to my fixed support, so that's going to be 3 joints. Okay. What about for an internal? What about for a hinge? All right. So if you have a hinge, it's going to kind of look like this, and they'll call it out. They'll say a hinge like this, which they're going to point it out. But for all hinges, there it has 2 reactions. Just to let you know. Okay. All right. I think that covers everything that we need to know. Let's go to number 2. All right. So number 2 says classify the beam shown below as statically determinate or statically indeterminate. So we are given that we have our supports, and we're also given members, and we're given joints just based off of the diagram, right? And we're trying to find the determinancy. Okay, so for this particular one, which formula what we need is similar. Going to be still in this frame section. All right, so how do we attack? How do we attack this? So we start out by writing out our equation, right? 3m plus r is equal to 3j plus c. All right. How many members do we have? M equal to, okay. This is a member. Then we have to break it, connect everything with the roller, and then this is a member. Okay. I'm not counting any overhang or anything, so we have two members. What about for the reactions? All right. Okay, so we have three at the fixed, one at the roller, one at the roller. So that is a total of 5 reactions. Okay. How many joints do we have? So to join this whole thing, I need to join it here. I need to join it here. I need to join it here. So I have 3 joints. All right, and so now once I do this equation, right, or plug and chug, I get this is equal to 3 times 2 plus 5 is equal to 3 times 3 plus 0. Okay, so I get 11 greater than 9. And so since 11 is greater than 9, then I know that it is going to be this bottom one again. Stable and statically indeterminate. By how many, to what degree? Statically indeterminate to the second degree. Okay. So for my answer, I get B. All right. Let's look at number 3. All right, so this one says classify the frame as statically determinate or statically indeterminate. Okay. So what information are we given? Well, we are given the supports, the reactions, the joints, and the members. Okay. Alrighty. So, and we need to find the determinants. Similar things again. What formula will we need? Well, we need 3m plus r is equal to 3j plus c. All right, what is m? Number of members. How many members do we have for this one? Well, we have one member here, right? But then we have to turn the corner, so it's another member. Right? Typically members are straight, they're not bent and doing a bunch of different things. So anytime you take a bend, you're gonna need a new member for that. So 1, 2, and 3. So we have 3 members. How many reactions? So this is a pin here, and this is a roller here. See the 3 little dots? Circles normally represent rollers. So we have 3 reactions. What about joints? So it's going to use orange. So I have to join from here to here. I have to join these 2 together. Join those 2 together because it bends. And then join this together. So we have 4 joints. All right, so when we plug and chug this, we get 3 times 3 plus 3 is equal to 3 times 4 plus 0. Okay. So then I get 12 equal to 12, which is equal to statically determinant. All right, everything's equal, so I would choose this second from the bottom, the one in the middle here, and yeah, we get statically determinant. Okay. All right, so that concludes determinancy section for structural engineering. In the next section, we're going to be looking at deflection of statically determinate beams, trusses, and frames. So I'll see you in the next video.